What is EROS? What is the idea behind it and what are the functional elements of it? This is the first video of the lessons introducing EROS and will give you a first overview about EROS. Before we get into the functionalities of EROS, the question arises as to what the robot controller actually has to be able to do. I would like to discuss this briefly here. An important purpose of any robot control system is, of course, that the robot can move in a meaningful way. A control system is responsible for this. A path planner calculates waypoints and thus set points for the controller from the specifications of the desired path movement. The controller compares the set point with the sensor values which it reads in using wheel and the position sensors. By means of algorithm, it then determines how much current it must be applied to the motors. These calculations must be carried out periodically with a high clock rate, for example every millisecond, which is why this process must fulfill hard real-time conditions. Usually several controls run in parallel and often with different clock speeds. In order to perform meaningful tasks, the robot must follow sequential processes. For example, the robot moves to an assembly station, places a part inside, releases it and moves away. In this case, it must be guaranteed that these steps are carried out strictly one after the other, because the robot cannot carry out two movements at the same time. However, if several independent manipulators or subsystems are involved, they can perform their own sequences in parallel at the same time. For example, a robot can open the gripper at the same time as it moves to the assembly station. When working through the sequential steps, exceptional situations can arise, for example, if the robot cannot grasp a part. In this situation, the robot must react with exception handling and adapt its next steps to the new situation. Sequential processes are often non-time critical, which is why they usually do not fulfill hard real-time conditions. Robots can be dangerous and put people at risk. It is therefore important that a robot only moves when it cannot endanger anyone. Therefore, a safety system takes over the switching on and off of power, electronics and motor brakes and monitors the correct functions of the software. If something goes wrong, the emergency handling system must take control, bring the robot into a safe state and also return it to normal operation. Of course, these functions must run in parallel in hard real time. In order to fulfill the mentioned requirements and for the hardware interfacing, EROS consists of the subsystem, control system, sequencer, safety system and hardware abstraction layer. The control system runs in real time. Blocks containing controllers, filters, observers or mechanical and dynamical models are periodically calculated. To ensure a temporarily correct flow of information, these blocks are connected by signals that transport physical information. The sequencer ensures that work steps run strictly sequentially, as the robot movements must be executed strictly one after the other. If an unforeseen event occurs, the current movement must be stopped and exception handling takes place. The safety system is designed as a series of hierarchical safety levels. It monitors critical inputs and outputs and ensures that a fallback of the emergency safety level will immediately and reliably cause the robot to stop, regardless of who or what triggered the emergency event. The hardware abstraction layer connects the software with the hardware, namely the sensors and actuators. In the so-called whole, digital information such as encoder ticks are converted into physically meaningful values such as angles or positions, so that we as software developer can interpret these values and apply physical formulas directly. You can get a first impression of how EROS is actually structured in the EROS template project, which is available on Git and for which there is also a video. We will use this template project to build the software for our robot step by step. If you have any questions, don't hesitate to ask them in the Moodle forum at online.robotics.ch. Thank you for your interest and see you in the next video.